Okay. So chapter 3 is regarding approximation rounding off. Why do we round off? First of all, why do we round off? Zores, why do we round off? Yes? Come on. Yes, Javeria?
To make the numbers more convenient for ourselves.
Very good. Yes. You know, like if somebody says that, let's see. Okay, if somebody says that there are 2,000,009, let's see, 296,743,2,1 people in, let's suppose I'm just coming up with a number in Riyadh. Okay, now isn't it hard to remember this number? It's so hard. I mean, 296,74321. I mean, you know, like you might get wrong in one of the digits. You might say 734 instead of 43. So it's really hard, and this is a big number, and it's inconvenient. So it would be easier if we round off to this, okay? Because you know we round it off to a number such as this, and we will discuss in a bit how we round off. So this is now, how many zeros are these? 6, 7. So 30 million. So now this is easy. Now you can easily remember this. Okay, there are 30 million population, you know, in Pakistan or Riyadh or whatever. So the point of rounding off is because it's not convenient to remember the exact number, and many times the exact number is not even practically that useful. I mean, what difference does this one make, or even these two make? Many of these digits, practically speaking, they are not useful. We can do without them. So what we need to know is a roundabout number. Roundabout number is more important, right? So if the government wants to build schools for people, or let's suppose the government wants to build facilities for 30 million, so 30 million will be a more useful number for the government rather than this exact number. Okay, so that's where rounding off comes in. Okay, that's why rounding off is important. Okay, so once we have talked about that, let's now discuss how rounding off is done. So the most convenient numbers that we have in our counting, if we look at counting, if we look at the numbers, most of the convenient numbers are multiples of 10. Okay, either tens or hundreds or thousands. Okay, these are the most convenient numbers. Okay, so now for example, let's take this example. I took this example from your book. Rounding off to the nearest 10. So we are starting with 10 because 10 is the simplest, okay, with only single zero. So what we are trying to find is that which 10 is it closest to? Which 10 is it closest to? So we will look at the 10s that are on either side of this number, okay, before this number and after this number. So before this number, the 10 that we have is 270, and the 10 that we have after it is 280, because the rest of them are 271, 272, 273, okay, 274 and 5, and then so on and so forth. So these are not 10s. I mean, you know, their last digit is not 0. Their ones are not zeros. Here the one is 0. You know the place values, right? So this is ones, this is tens, and this is hundreds. This you must have done in your junior grades, right? So when I'm saying the ones digit is 0 here, the ones digits are not 0 here. Okay, so this 275 is exactly midway between these two tens. So by convention, what is a convention? It is a rule that is followed universally by scientists or everybody. Okay, so by convention, we choose the 10 which is after the number. If the number is exactly midway between the two tens, then we choose the bigger 10. Okay, this is by convention. If, for example, the number was 271, now which 10 is it closer to? Now this is very evident on this number line. Which 10 of the two, which 10 is 271 closer to? Yes, Abdul Rahman?
Ma'am, we cannot see your screen fully, like it's so small.
I spotlighted it for everybody.
Uh, if I send a screenshot of from my screen to your WhatsApp, you can check it out. From
No need to do that. Let me.
He should use gallery view. There's a button over there. He can click on that and then he can see it.
But it's spotlighted.
Ma'am, I can see perfectly. It's fitting my window.
Yeah, it's a spotlighted, and there's I don't think I can do anything else about this. Can we? Yeah. Okay, Abdul Rahman, are you attending after a long time?
yes, miss.
Okay, try maximizing it, or try some other view like gallery view, or
Speaker view.
yeah, or otherwise leave the meeting and re-enter. You might try doing that. Okay. Okay, yes, Sabiha. So which of the two tens is 271 closer to?
280.
280? 280 is here, and 270 is here, and 271 is here. So which is it, to which 10 is it closer? Can you see? It is closer to, yes, Javeria?
270.
Yeah, it's closer to 270. So if the number is 271 and you don't exactly remember whether it was 71 or 72, then what will you say? You will say about 270. Some digit after that, but I don't remember. But yeah, it was close to 270. Okay, so this is the 10, 271 is closer to. And can you see the number is going to stay closer? All these numbers which are before 275, all these numbers are going to be closer to 270 as compared to 280. But when the numbers get bigger than 275, for example, 276, 277, 278, 279, now these numbers are closer to 280 as compared to 270. Okay, so all these numbers will round off to 270, whereas all these numbers will round off to 280 because they are closer to 280, and these numbers are closer to 270. Okay, now this was my explanation on the number line, and this was on the number line. Now I will continue this explanation on number line. Now if somebody asks you to round this off to the nearest 100, round off to the nearest 100, okay, you can think of these tens and hundreds and thousands as landmarks, and then you have to find to which of these landmarks or to which of these hundreds is the actual number close to. Now if I am rounding off to the nearest 100, I should know the 100 which comes before it and the 100 which comes after it. So the 100 that comes before 275 is 200, and the 100 that comes after 275 is 300. Now tell me, of the two hundreds, which 100 is this 275 close to? Yes, Aliha?
300.
Yes, we can easily see that it is close to 300 as compared to 200. It's very far away from 200, right? So we will say some number close to 300. If we cannot remember it, but we will still be able to remember that whatever that number was, it was close to 300, right? So this is how we are going to round off a number to the nearest 100 on a number line. Now, it is not convenient to draw this number line all the time, okay? So we have come up with a method where we won't have to draw this number line and we can just directly round off. Okay, so let's do that method first. Okay, now 275 nearest 100, sorry, nearest 10. Let's do that first. So we know this is ones, this is tens, and this is hundreds. Okay, now when they say nearest 10, the first step is, by the way, these steps are mentioned in your book. These steps, I am teaching the same steps. Okay, so for example, okay, let me use this. Round off each of the following numbers to the nearest 10. Part A is 275 to 275. So this is ones, this is tens. So because the question is asking you to round off nearest 10, we will pay attention to this digit. We will pay attention to this digit, 275. This is tens. And then we will look at the digit which is right next to it. We will pay attention to the digit which is right next to it on the right hand side. Right next to it on the meaning on ones, in this case on ones, the digit which is on the right hand side. If this is greater than 5, if this digit is greater than 5, then this tens digit would increase by 1. For example, if this is 7, after it increases by 1, this becomes 8. And the rest of the digits will be copied as they are. Okay? And what happens to the digit which is next to the digit that we rounded off to? That will convert into 0. Why is that important? Why is that important? Why can't we just leave it? Why can't we just write 28? Yes or is? Yes or is? For example, if we have 263 and we round this off to the nearest 10. Now this is ones, this is tens, and this is hundreds. Right, rounding off to the nearest 10. So I will underline this. I will look at the digit next to it. This is 3. 3 is smaller than 5. Okay, so if it is smaller than 5, what do? This stays as it is. This does not increase by 1, but it stays as it is. Okay, I copy the rest of the digits and this ones becomes 0. So the digits on the right hand side of the digit that you changed, they become 0. They get converted into 0, whereas the digits on the left hand side are copied as they are. The digits on the right hand side of the digit that you changed due to rounding, or which is the same place as the nearest place that was given in the question. The digits to the right hand side of that digit will all become 0, whereas the digits to the left hand side of that digit will be copied as they are. Okay, we'll do more practice and then you will understand. And I think most of you already know this, but okay. So why is this important? My question is, why is this writing 0 important? Could we just write 26 and then leave and not write 0? And then why would that be wrong?
Because then how come from a bigger number?
Please reply loudly.
Because then how come from a bigger number you got such a small number? If you're rounding it up, it should be smaller, but not so small like the 26.
Should it be smaller?
No, it depends on the digit.
Reply loudly so that everybody can hear you.
It depends on the digit.
Yeah.
Like it's up, like when
right.
You're rounding it to the nearest 10, nearest 100.
Yes. So not necessary. See, yes, Sabiha. Yes, Sabiha?
I wanted to answer your question.
Yes, please answer. Yes.
Then you wouldn't be rounding to the nearest 10. It wouldn't be a 10 or the 100.
Yes. Okay. Yes, Wania? Yes, Wania?
Miss, because it's significant.
No, beta, we haven't discussed significant as yet. Yes, Javeria? Yes,
If I
Javeria?
change the place value, like we'll change the place values.
Yes.
The tens would becomes the ones and the hundreds would become the tens.
Yes, yes,
And
yes.
that doesn't happen. We're not supposed to change the place values. The place values are supposed to stay the same, but the numbers should be
Right.
changing.
Right. Yes, all of you gave correct answers. So remember, in rounding off, make sure that your answer should have round about the same value as the number that was given in the question. You cannot go too far away from the actual number. Rounding off meaning like it should be approximately, it should be close to the actual number, right? So you cannot go too far. Okay, so 26 is nowhere almost the same as 260. There's a big difference. There's a difference of there's a difference, there's a big difference.
100.
Okay, yes. So remember that your answer should have roundabout the same value as the actual question. Okay, now let's do this example. Round off each of the following numbers to the nearest 10 to 73.1. Can I get some rough papers? 273.1. 273.1. So again, I will look at the tens digit. Where is the tens digit here? Bring the whole thing. Where is the tens digit? Yes, Sabiha?
Then the 10th digit.
Yes. So where is the tens digit? So nearest 10, right? I have to round off to the nearest 10. So that means I need to first find out which one is in, which digit is in the tens place. Okay, that's going to be my first step. Yes, Javeria?
Seven is in the 10th place.
Yes, so this is ones, okay, like a whole number. So this is a whole number. So this is ones, this is tens, and this is hundreds. Okay, what about this? This is 10th. There is th, 10th. Okay, 1 over 10, 10th. And you know, if you have more, then you have hundredth. If you had another digit here, it would be hundredth, and then you have thousandth, and so on and so forth. Then you have 10,000th, and you can go on, you know, okay? So here you have just th being added. Here you don't have ths, okay? Okay, so 10, so this is 10. So again, I will look at the digit on the right hand side. It is smaller than 5. And so this, of course, will become 0 because this is the digit that we were looking at, because the question asked us to round to the nearest 10. This is 10. So all the digits on the right-hand side will become 0. This will stay as it is because this digit was less than 5. If this was more than 5, then this would have increased to 8. But this will stay as it is, and this digit will also stay as it is. What about this? This would also turn to 0, right? This would also
Yes.
turn, yes. So you can just write 270. Okay? Okay, let's do a few examples. And then, have you guys done all these practice now questions? Which question do you want me? Which exercise do you want me from this? Do you want to do practice now 1? Practice.
Practice now 1.
Practice now 1? Okay. Have you done this with the teacher, or the teacher only does the exercises with you guys?
Teacher, I did the practice now 1 with my teacher.
Oh, okay. Yeah, I think teachers are doing practice now. So do you want me to do
No.
again?
You
Or you
have to
guys?
see your face.
Okay, let me just do 2 or 3. Let's do 3, 4. So the question is that you have to round off 3, 4, 0, 9, 7, 2, 5 to the nearest. Which one do you want to do? To the nearest 10, 100, 1,000, 10,000?
It's your choice, teacher.
Okay, 10,000. Let's do to the nearest 10,000. Okay, nearest 10,000. So for this, we have to know which digit is on the 10,000 place. Which digit is it? Sidra?
9.
Ones, tens, hundreds, thousands, thousand. th नहीं है, th नहीं है, क्योंकि because th is after the decimal. 1,000, 10,000, 100,000, and yeah, 100,000, 1, 2, 3, 4, 5, 6, and this will be million. Okay, so I want 10,000. So 10,000 is, this is 100,000. This is 10,000. 0. Ones, tens, hundreds, thousand. Javeria, am I correct?
Yes.
Ones, tens, hundreds, thousands, and this is 10,000. Okay, and this is 100,000. So 10,000 is this digit. So we will look at this digit. What about the digit right next to it?
We'll use it as a power and it will change to 0.
It is greater than 5. Greater than 5. Then that means this will increase by 1.
1.
Yes, and then all these will turn 0. Okay, so this should be your answer. 3, 4, 1, and then this. Okay, how do you know? Nearest 10,000, how many zeros are in 10,000? 1, 2, 3, 4. Your answer should also have 4 zeros. 1, 2, 3, 4. Okay? Okay, now you guys will do. Okay, so that I know that you have understood. Nearest to 1,000. Same number. Nearest to 1,000. Zores, yes? Yes, Zores?
Near to 1,000, my sir told me that we will underline 9, put a dot
Yes.
under 7.
Yes, okay, we will underline 9. Why? Also explain us the reason, because
We'll
this is
put
in the thousands place, right?
yes,
Tens, hundreds, so 1,000. So this is 1,000. So okay, I will underline this, and then we'll look at the digit next to it.
the digit next to it is above 5.
Right?
So we will write 3, 4, 34.
Yeah, so now if I increase this by 1, 9 plus 1 is 10. Right? So there is no other way but to carry 1 on the other side, you can say. And so this becomes 1, and these will be copied as they are. And this happens only when you have 9, and when you are increasing to the next digit, it becomes 10.
And we'll make the next, and we'll make the other numbers.
Yes, all the other numbers will be converted to 0. Now, so that means it is not all the time necessary that your answer should have the same number of zeros as to the nearest, because there are situations like these. Okay. Now, can you see that when we rounded off this number to the nearest 10,000 and when we rounded it off to the nearest 1,000, we are getting the same answer? Yeah, that is very much possible. Yes, Abdul Nafi, you want to say something?
No, no, ma'am.
Okay, okay. So should we move on? Okay, let's do practice now to correct this to 1 decimal place and to the nearest 0.001. Let's do this. I need more papers, Sidra. Okay, so let's do this. 78.4695 to one decimal place. So whatever they are asking, whatever they ask in the question, you underline that digit. Okay, so one decimal place meaning one place after the decimal. That means one place after the decimal or one digit after the decimal. So this is going to be underlined. And then we are going to look at the digit on the right hand side. Okay, let me write it again here. Okay, so yes, who's going to do this with me? Abdul Nafe, you want to do it?
Yes.
Yes, okay. So we will underline this because this is one decimal place. This is one place to the right of decimal. So look at the digit right next to it. I mean, on the right hand side.
Okay.
So it's greater than five, right?
Yes. It is greater than 5. So we will move it to the, we will turn 4 into 5.
Very. So this will increase by 1 and all these will become 0,
0.
right? Decimal will stay as it is
Yes.
and the rest of the digits,
Will come as it is.
yes, will be copied as they are. Okay, so that is going to be our answer. No need to write so many zeros, just 78.5. Okay, why? Because when the answer says one decimal place, so remember that your answer should have only one digit after the decimal. So omit these zeros. Okay, now let's do, if they say two decimal place, then of course you should have two digits after the decimal. Okay, now,
Ma'am,
yes,
won't we like do 78 as a whole number too because it's 5, so we won't do it 79?
Beta, it depends upon the question. The question asked us to round it off to one decimal place. So it can be 79 if we round it off to the nearest whole number.
Okay.
Yeah. So it depends upon, okay, you want to do through the nearest whole number? Yeah, this can be rounded off. Let's do it to the nearest whole number. Okay. Round it off to the nearest whole number. Okay. Same number, 78.4695. Sidra? Okay, so nearest whole number, then you will take the digit right before the decimal because this on the number on the left side of the decimal is the whole number. This is called whole number. Okay, the digits after the decimal, these are part of the whole number. They are part of a whole number. They are not the whole thing. Okay, they are some fraction of the whole number. Okay, this is the whole number. So when they say round to the nearest whole number, then that means you, because the last digit, you will look at the last digit. Okay, the digit that comes right before the decimal. Okay, so now look at the digit after it. It is, so is it greater than or less than 5?
It's less than 5, so it'll stay the same, like 70.
No, it's not stay the same.
It'll turn into 0, but I'm talking about the 78.
Yeah,
Stay the
this
same.
will stay the same, right? And this will also stay the same, right? And
And the
all
rest will
these
all
will
be
become
0.
0. And the decimal is still there. We won't write all of these. So when it is rounded off to the nearest whole number, it is 78. Okay? Okay, Abdul Rahman?
Ma'am, but we cannot take 6 to 4 and 4 will turn into 5.
No, beta, you don't start rounding off from the right hand side. You will round off only from that place which they have asked in the question.
Okay.
Yeah. Okay. So if
Is this
one
a
that,
new thing?
yes, what?
Because we did not learn this.
Oh, you haven't done this in with the
No.
with the school?
No. When I was in 6, there was nothing like this.
Which grade are you?
9.
And you're attending rounding off class here with grade 6.
Yeah.
Well, that's appreciable. That's commendable. I like it. Yes, you should brush up on your basics. The basics are really important. And I have seen 9th and 10th graders, they don't know even grade 5 stuff. Some of them don't even know grade 5 and 6 stuff. So yes, no, we round off to the digit that is asked in the question. Okay, because otherwise, the number is very big, and if you start rounding off from the right hand side, you will get incorrect answer. Okay.
Okay, thank you.
Okay, now to the nearest point 001. Same number, but we will round it off to the nearest point 001. Now, this is just another way of saying round off to the 3 decimal places, to 1 decimal place, 3 decimal places. Just another way. Like they could have, this can also be written as round off to the nearest 0.1. Same thing, meaning 1 digit after decimal. 3 digits after decimal can also be read as 3 decimal places. Same thing. Okay, now if the number is the same number, 78.4695. So that means this is the digit, this, which has the 3rd place from the decimal. So 10th, 100th, 1000th. Okay, so now I will look at the digit next to it. It is exactly 5. And by convention, if you get the digit exactly 5, then you just, this becomes 0 and this will increase by 1. But because this is 9 and 9 gets increased to 10, I will carry 1 here. This will also become 0 and this will become 7. And the rest of the digits will stay as they are. And so my answer would be, and now be careful. If the question wants you to write only 3 decimal places, you should write only 3 decimal places. Omit this 0. 78.470 is my final answer. Yes, or is? Yes, or is? Zoris? Yes? Okay, let's move on. 3A. I think we have done this. We have done exercise 3. It's the same thing. Round off 698,352 to the nearest 100, 1,000, 10,000. Same thing. Okay. Okay, we have done all of this. Let's move on to the next. Okay, significant figures. Yes, this is a little hard. Yes, who will tell me what significant figures are? Yes. Who wanna tell me what significant figures are? What do you understand by significant figures? Can I get more papers? Yes, Javeria. Very good.
They are more accurate. They have more accuracy. They're not rounded off.
Right. Good job. Yes. This is one meaning that, significant figures, the more accurate a figure is, more significant figures it has. Okay, so more the significant figures. What does significant mean? Significant mean like you are sure about that digit. The more digits you are sure about, the more accurate that number is, and therefore all those digits are significant. For example, okay, let's okay, for example, you have 32. Let's say I say that I have 32 apples. 30. If I say I have 32 apples, now am I sure I have exactly 32 apples? I mean,
Yes.
or you mean to say, if somebody can ask me that, are you sure you have exactly 32 apples? Or they can be 35, 34, 33, and this is just an approximate. This is your approximation. You think they are about 32. they can be 30, 31, 32, 33, 34. They can be any of these numbers. Is that the case, or do you exactly know that they are 32? They are not 33, they are not 34, they are not 31, they are not 30, but they are 32. So you are confirmed about this digit and this digit. Are you sure about both these digits? Then I will say, you know what? I didn't really count them. Maybe I got wrong. So yeah, I think they're about 30. If I say that, if I say no, maybe I did get wrong. Maybe they're about 30. When I say that, that means what? That I am only confirmed about the tens digit. I am not confirmed about the ones digit. One can be 1, 2, 3, 4, can be any of these. Can be 31, 32, 33, 34. I don't know. Maybe.
So
But
you're not being
so,
exact.
yes, so that means I am only sure about this digit. But because, so then, the next question might be, are you sure that they were about 30? Like they were not about 20 or about 40? And then and then my reply would be, oh no, they were not 20 and they were not 40, but they were around 30. So that means my tens digit is not 2 and it is not 4, but it is 3 for sure. So I am sure about tens. If I am sure about tens, then that means this number has only one significant figure. This has only one significant figure. So in other words, how many digits are you sure about? That those many digits will be significant in a number. Did you get me? So if I say no, I counted 3 times, 5 times, and they were 32. Exactly. They were not 31, 30, or then that means I am sure about this tens digit as well as ones digit. Now this will have two significant figures. Now, another scenario. If I say I counted exactly 5 times and all 5 times I got 30, exactly 30. 3 and 0. I am confirmed about this 0. It was 0 and it was not 1, 2, 3 or any other digit. It was only 0. Then that means I am sure about both of them. That means both of them are significant. So this also has two significant figures. So it depends upon how sure I am about the digits. The more sure I am about the digits, the more significant figure that number is going to have. Did you understand? Did you understand this much?
Yes.
Yes. So it has to also significant figure. Also, it has to do. So one thing is accuracy. How accurate, how sure you are, how accurate and how sure you are. Sure means accuracy. Third, how important a digit is. For example, in this number, which digit is more important? Now, what do I mean by important? Important means which digit is contributing more towards the overall value of this number. Is 2 contributing more, or is 3 contributing more towards the size of the whole thing, towards the size or the value of the whole number? Yes, Sidra? Which digit is contributing more?
3.
Say it loudly, please.
3.
Why?
Because it's around 30, and you're not sure that it's 1, 2, 3 or 4.
No, I did not say that. I just said that that story is over about being sure. Now I'm just talking about the size. Which one is contributing more towards the size of the whole number, towards the value of the whole number?
Yeah, but 3, because 3 is bigger. Is a bigger number than 2.
Yes. 3 is a bigger number. It is contributing 30. 2 is only giving 2 ones. So its contribution is less. This number's contribution, this digit's contribution is more. So that means higher the place value, more the significance. So that means 3 is more significant than 2. Though both are significant, if I'm sure about both of them are going to be significant. But this is more significant, okay? Because we are more sure about this usually. And this is also contributing more towards the overall value of the number. So also remember that. Okay, so once we understand that, now the rules, okay, the rules. Now, when I was a student, I ratified them, okay, but that was one reason why I also forgot them, because I did not understand them. I don't want you guys to do that, okay? Let's try to understand at least, and I have explained them in that recording of mine, that the link of which I shared in the group. Please go ahead and watch it, okay, if you get time. All non-zero digits are significant. Well, that is very common sense. Everybody understands, right? 7258. So if anybody says that, let's suppose a school has 7,258 students, he must be sure. That's why he is giving you such an accurate number. He must be sure, right? 7,258. So if these are non-zero digits, they are all going to be significant, okay? That's easy. I don't think there is any big story here. Okay, now all zeros between non-zero digits are significant.
If you round it up, you will get zeros.
Yeah, if you round it up, then you will have zeros, right?
So how
Because you are rounding to the nearest 10 or 100 or 1000, and so you will have zeros.
So then how?
So we are not talking about zeros here. We're talking about non-zero. Yes?
Rounding off is not significant. That's why we have zeros over there.
Yes, very good. Yes. Okay. And in rounding off, we are only considering the digits nearest to which we rounded off. Okay. And we will come to that in a bit. So now, if you have zeros between non-zeros, like such as this, so this is also significant because why? Why? Because of course this is not a product. Yes, Javeria?
Because it's in the middle of the significant numbers, and as well it has a place value.
Exactly. Yes, it has a place value, as well as like you don't add zeros in the middle when you approximate, right? You either add at the end or maybe in the beginning. You don't add in the middle when you approximate, right? So if there is zero in between the non-zero digits, that means it is there, okay? So that is why it is significant. These two rules are easy to remember, easy to understand. Okay. Now, the third rule. Okay. In a decimal, all zeros after a non-zero digit are significant. Now, they have given this good example. Now, let me use this example. This ruler has only 0.1, 0.2, 0.3, 0.4. These are the divisions on this ruler. And look at the divisions on this ruler. Even between 0.1 and 0.2, it is further divided into 10 smaller and equal divisions. So that means if anything measures in between 0.1 and 0.2, we can use these smaller divisions to give us exactly, you know, how long the thing is. Where exactly between 0.1 and 0.2 is the length of the object. Whereas using this ruler, if the length of the object is exactly on one of these marks, only then you are sure, absolutely sure, 100% that, okay, this is 0.6. But if the thing happens to be between 0.5 and 0.6, then you are unsure. And all you can say is, okay, it is between 0.5 and 0.6. That's all I can say. It is between 0.5 and 0.6. So this is more accurate. Okay. So what is the most accurate reading that you can get or the least accurate reading that you can get, not most, least accurate reading that you can get using this ruler. It is closest to, it is nearest to 0.1, right? And here it is closest to 0.01, right? Because each small division is 0.01. 0.1 divided by 10, so you get 0.01. So this is more accurate. So this is giving you 2 decimal places. Okay, for example, did you understand? For example, this will give you, for example, 0.65. If something is exactly in the middle, this will give you 0.65. 65 has 2 decimal places. This can only give you accurate to 0.6 or 0.7. That's it. It can even give you only 1 decimal place reading. This can give you only 1 decimal place reading. This can give you 2 decimal places reading. Okay, now when we say 0.60, what does this mean? This means that the person is sure that the reading is not 0.61, or it is not 0.62, it is not 0.63 or anything, but it is 0.60. So when you write 0 at the end with a decimal, you do it only when you are 100% sure that yes, it is 0.6, exactly 0.60, meaning that the length is not moving even a tiny bit ahead of 0.6. It is exactly on 0.6. That's why we wrote that there is no other decimal, there is no other non-zero digit after 6. So I am pretty sure about this. Okay, that's why they added. This is to emphasize that there is no other non-zero digit after 6. It is 0 and only 0. That means they are sure about this. They are sure about this. So that is why this is significant. This 0 is significant. And this is also significant, 6, because it is a non-zero digit, and this is also significant. So, but remember, the zeros at the end are significant only when you have a decimal. When you don't have a decimal, that's a different story we will discuss later. So in a decimal, remember they added, in a decimal, all zeros after a non-zero digit are significant. Okay, because they are sure about them. Now, other rules. In a decimal, all zeros before a non-zero digit are not significant. What does that mean? Yes, Javeria?
It means all the zero digits, before a non-digit number. For example, there's a number 0.0002. So all those zero before the 2 are not significant.
Yeah, why? See, they have given a very good example here. They have given a very good example here. For example, if somebody measured something and it was 5.7 centimeters long. If, for example, I measured something and it was 5.7 centimeters long. Let me use a marker. Okay. Now, if I convert this into meters, if I say, no, I need the measurement in meters, okay? So now 100 centimeters in 1 meter. And so I will divide this by 100, right? And I will get 0.057 meters. Is that the number I will get? Yes, the decimal will move back twice, two places. So I will get 0.057. So now I have how many decimal places here? 1 decimal place. And I have 2 significant figures and I have 1 decimal place. So my accuracy, see, accuracy also has to do with decimal place. So the more the decimal places you have, that means more digits you are sure about, right? More digits you are sure about after the decimal, that means you are very accurate. So I have only 1 decimal place. So my accuracy was only 1 decimal place because I used a centimeter ruler. to measure whatever I measured, 1 decimal place. But when I converted it and when I recorded my reading, I am giving my answer in 3 decimal places. My final thing is 3 decimal places. So does that mean that no accuracy increased? Because see, there is an increase in 2 decimal places. Did the accuracy increase? No, no way. Accuracy increases only if you use a more accurate instrument. Like if I used, instead of a centimeter ruler, if I use a vernier caliper, or if I use a micrometer screw gauge, only then if I get a 3 decimal place reading, I can say that yes, this is more accurate. But can you see now the number has 3 decimal places? Does that mean that accuracy increased? No, accuracy did not increase. Therefore, these zeros can come in due to various other reasons. They can come in due to multiplications, due to divisions, okay? So therefore, these are not reliable. We cannot count them as significant, okay? Not all the time. So we cannot count them as significant. Therefore, it is a convention that these zeros, which are before non-zero digits and with decimal, they are considered not significant. Yes, Javeria, I can see your hand raised. Yes.
Ma'am, so that means that the centimeter scale is more accurate than the meter scale?
Well, yes, it should be. It depends upon the divisions. What is the smallest division? Yes, so I think centimeter would be more accurate because it will have more smaller divisions. So the smallest, the smaller, the smallest division is going to be, the more the accurate that instrument is going to be.
Thank you.
Okay. So you understood all these rules. By the way, they have not written one rule. Have they written it? No, they did not write that rule. Trailing zeros. What about the trailing zeros? They did not write that rule. Why? Okay. Okay, no, but that is very important and I will mention it. Okay. For example, now, by the way, I have already explained it when I was explaining this 32 thing. Where did that go? Where I was explaining that 32 apples. Where did that go? That page. Yes, here when I was explaining you this. So did you see that how in this case, when I said it is about 30, so because I was not sure about the ones digit, this 0 was not significant because I wasn't sure about it. So therefore this was not significant. But here I was sure. I said, yes, they are exactly 30. So if I am sure, then this is significant. So the trailing zero meaning zeros that come after the non-zero digit without a decimal. I'm not talking about the decimal. Okay, this rule I cannot see in the book, but this is very important. The zeros that come at the end without a decimal may or may not be significant. Oh, by the way, now I remember. These type of questions were given in the worksheet, and because this rule was not in the book, the teacher sent a separate video in the group to explain this rule. Okay, so it depends upon how sure you are. May or may not be. In the book, I think they will give you 2 answers. It depends upon the situation, and I will give you examples of situation. One example I have already given you. I will give you another example. Now, for example, if you are sure about all these zeros, then that means 1, 2, 3, 4, 5, 6. There are 6 significant figures. Okay. And if you say, no, about 300,000, then that means you are not sure about any of these. They can be any digits. That means only this is significant. So can also be only one significant figure depending upon how accurate this figure is. If, for example, somebody says, no, I am sure about these digits only to the nearest 1,000. I'm sure to the nearest 1,000. Okay. So that means I am not sure about these two. These may be 2, 1, 2, 3, whatever. But here I am sure that they were 3000. But about these two digits, I'm not sure about the last two digits. That is another way of saying that this figure is approximated to the nearest 1000, because 1000 is the last digit I'm sure about. Ones, oh sorry, this is hundreds. Sorry, this is hundreds, right? This is ones, this is tens, and this is hundreds. Yeah. So hundreds is the last digit I'm sure about. So that means I am sure to the nearest 100. Then that means they are not significant, and the number of significant figures would be 1, 2, 3, 4. 4 significant figure. So depending upon the situation, my answer will depend. Okay, so these trailing zeros may or may not be significant depending upon the situation. If, and now I'll give you an example, just last example. If, for example, I say that the pages of my science book are 100, pages in my science book are 100. Do you think, now if you are given this question, that the pages in your science book last page number is 100, last page number is 100, how many significant figures? Yes, Aisha?
2.
Why 2? Which figures have you included and which have you not included, and why?
I've included the first 2 because there might be 1 or 2 more pages or less.
Okay, pay attention to the wording of my question. I said the last page number is 100. Now, would you like to change your answer, Aisha?
No.
Okay, yes, Sidra?
It's only one significant figure because you're not sure, because in a book it also includes the first four first pages, and they start counting after the contents in books.
Okay,
So like if it would be the end, that would mean you have 104, 105.
okay. Yeah, so
And it was the last page number.
see, if my question was that the last page number is 100, and so how many significant figures? My question is not how many pages were there. That was not my question. I didn't ask how many leaves of pages are there in the book. My question was last page number is 100 and tell me the number of significant figures.
Oh, so there's
May I?
Yes, Javeria?
side.
The answer is all 3 digits are significant because you are sure that there are 100 pages in your book.
Yes, thank you. Yes, Jazakallah khairan. Yes. I think Javeria is the only one who is listening to my recordings and also paying attention. Sidra, did you understand? See, this is the last number on the page. So when I am telling you the number on the page, I am looking at the number and I am telling you the number myself. I am not approximating. This is 66, but I'm just giving you an example. Okay. Beta,
Look, they're like one V, one this. These are also pages.
yeah, these are pages, but my question was not how many leaves are there, how many pages are there in the book. That was not the question.
Oh, it's okay. I got it. It's a last page number.
Yes. Okay. So you have to pay attention to the wording of the question, and you have to again you have to see how sure the questioner is about each of these digits. Okay. Okay. So this was one example. And if somebody says a population of Pakistan is 24 million. Now, tell me the number of significant figures. Somebody else other than Javeria? Yes, Aisha?
2, 2 and 4.
Yes, only 2 significant figures. Okay, because we are not sure about these. These can be other digits. Okay, so these 2 only will be.
Ma'am?
Yes. Yes.
This digit could also be rounded off. 4 could have been rounded off. It could be 3 before, earlier. So
Okay. Yeah. So when they will be rounded off, then you can deal with them. But right now, if the question gives you this figure and they ask you to, to give the number of significant figures, it is going to be 2. Okay. So this is already rounded off. This is already rounded off. So at this particular stage, I mean, of course, this can be further rounded off to this. Okay, but we are not talking about this. The question is talking about this. So the question is, it seems from the question, it seems that they have, because they themselves wrote 4, that means they are pretty sure about this 4, right? And non-zero digits are significant. So there are 2 significant figures in this particular question. Okay. Okay. So yeah, this is a little tricky to understand. Yes, yeah, I know, it's 641. Okay, let's do this. Round off each of the following to the number of significant figures as given in brackets. Let's do like 1 or 2 from here. So let's do this last one. 0.09, and then there are 4 9s. And then you have to come here, Sidra. Come here, sit down. Round off to 2 significant figures and then 3 significant figures. Okay. Okay. Now, when they say round off to two, for example, 2 significant figures, we are going to start counting from the left-hand side. Because why? Because I told you higher the place value, more the significant. So we cannot omit the more significant digits. We know these zeros are not significant. Okay, the zeros that come before with the decimal, they are not significant. Even without the decimal, they are not significant. So this is the first significant digit, and this is the second significant digit. So we will underline this, or you can circle whatever, and then look at the digit next to it. This is greater than 5. Yes, Zores? Yes, Zores? You want to do this with me?
Yes. Right.
Okay.
We are doing it by 2 significant figures.
Yes.
And the first 2 significant figures are from the left side are 2 9s.
Yes.
We underline the second 9 and
Yes.
put a dot under the third one. We will see if the third number, a third digit is bigger than 5 or is 5.
Yes.
It's 9, so it's bigger.
Yes.
The answer would be 10, carry 1. Then the other answer will be 10 as well, so another carry 1. So the answer would be 0.1.
0.1 or 1.0? This was greater than 5, so this increased by 1. When this increased by 1, this became 10. Because this became 10, this became 1. And so 1.0. Okay, now your final answer is going to have 2 significant figures only. Okay, so that means, so starting from left, 1 significant figure, 2 significant figure. You will omit this. So 1.0 will be your answer. Your answer cannot have more significant figures than is mentioned in the question. So you will not write 1.00, because what does that mean? That means you're giving 3 significant figures. Yes, now, if they ask you 3 significant figures, then the answer is going to be 1.00.
ma'am,
Yes?
the zeros after the decimal don't matter. I mean, 1.0 is the same as 1, and 1.00 is also the same as 1.
Listen, you are only looking at the value. What does this mean? We have 2 decimal places. That means we are very sure that up till 2 decimal places, the digits are 0. They are not any other digit. I am really sure. This shows that I have put a decimal and I have added 2 zeros. That means I am really sure about these 2 digits. So therefore, this has more accurate. This is more accurate than this. This is more accurate than this. And that is why it has more significant figures than this. So yes, value is the same, but this is more accurate and this is more significant. The overall value is the same, but this is more accurate. It's like this, you know, look at this. 6.72 is more accurate or 6.7?
6.72.
Yes.
72.
Because we know
Yeah.
that the next digit will be 2
Yes.
and not any other
Right.
unknown digit.
Yeah. If, for example, I write 6.0 and I write 6.00, what does that mean? That means this is more accurate, meaning I know about 2 digits after decimal that they are 0. I am sure, that's why I wrote down. Do you know that in some conditions, people write just like this, not even a single 0? What does that mean? That means there is decimal here, but the person who has written is not sure about the digits after the decimal, if they are 0 or 1 or whatever. Most probably it's 0. You can take it as 0, but the writer is not sure. Can be other digits.
I get it. Thank you, miss.
Okay. Okay. So I have, I did one question from here. Okay, let me see. I think I have completed almost all the concepts. Yes, I know it's 640. I know that. State the number of significant figures in each of the following. Is there any question? Is there anything I have missed on and you want me to do? Because I won't be doing this topic again. I have already done it twice. Yes, Ishal? Ishal?
I think, Miss, I wanted to do the answer, so I forgot to run.
Oh, okay, Zores.